My name is Reshwan. I'm with NEPRS. I'm going to be the moderator for this session. So just to let you know that this session is set up as a webinar. So students, if you're on here, you'll not be able to start your audio or video, but feel free to go ahead and send us your questions through the chat button or the Q&A tab that you see on your toolbar. Teachers, if you're on here and you'd like to be promoted to being on the panelist side so you can see which of your students are in attendance, feel free to let me know so I can go ahead and promote you. And we will begin the session shortly, in another minute or two. If you have questions about technology or such, let me know. Lydia, I think I saw another presenter too. Is he joining? Do you know?
It should just be Tim and me in this session.
Okay. All right. Sounds good.
Yeah.
All right, everybody, welcome again. Just letting you know that teachers, if you are in this meeting as an attendee only, please let me know so I can go ahead and promote you to being on the panelist side so you can see which of your students are in attendance. And students, you'll not be able to start your audio or video. So if you have questions for our presenter, use the Q&A tab or the chat tab that you see at the bottom on your toolbar to send us questions. All right, Lydia, I do see we have several participants already on here and it's a minute past. So are you and Mr. Christensen ready? Okay. All right. Good afternoon, everybody. So this afternoon, we have Lydia McDowell and Tim Christensen from the Boeing Company. They are going to introduce themselves and talk to you all about their career. So Lydia, introduce yourself and take it away. All yours.
Hi, everyone. My name is Lydia. I'm a liaison engineer at Boeing Portland. I'm going to start presenting slides and I will hand it over to my colleague, Tim, and then I'll meet you and talk a little bit more about what I do. Okay, you should be good, Tim, if you want to unmute.
Okay. Hello, everyone. My name is Tim Christian. I'm a manufacturing engineer with Boeing Company here in Pandora. And we're going to lead off with our president in manufacturing and aerospace. Next slide, please. Next.
Tim, it seems like you might be having some connection issues with your audio and video. Can you hear us okay?
Mr. Christensen? I think we lost him. So Lydia, are you able to talk to us about your career while we get Mr. Tim back?
Yeah, let me go ahead and start from. All right. All right. My name is Lydia. Like I said, I'm a liaison engineer with the Boeing Company, and that might be a new word for you. So hopefully by the end of the presentation, you'll understand a little bit more about what I do here at our Portland factory site. So really this picture, to me, in a nutshell, says it all. Engineering is a really highly collaborative career, and it requires both left brain and right brain thinking. So our left brain is kind of our logical, rational, analytical side, and then the right brain is where all new ideas, creativity, synthesis, artistic talents come out of us. And because we're building things that have never been created before and we're solving problems, we have to leverage both sides of our brain every single day. My journey in engineering started when I was in high school, and my pre-calculus teacher told me, "You really like airplanes. Well, you wouldn't have to exactly be a pilot. You could actually design them and test them." And I was like, "Oh, wow, there are people that do that," and that kind of really opened up and paved the way for me to start looking into engineering as a whole, and then funneling it down eventually into aerospace. So I took basically all of the math and science classes that I could in high school, and any prerequisites for my freshman college classes that I could. And I made sure that I was also, I was involved in anything science related. So science competitions, science fairs, community projects like Habitat for Humanity. I was the president and founder of our environmental club. So at an early age, I guess, I was able to be in these collaborative team building environments that set me up for success in college. So I did my undergraduate, I got my Bachelor of Science in Aerospace Engineering from West Virginia University. That took me 5 years because I got a dual Bachelor's of Arts in Foreign Languages. And you can kind of expect the same core requirement classes for any engineering career that you choose. You're going to have to take 4 semesters of calculus, physics classes, chemistry, English writing, and your core extracurriculars. And then once you get into kind of like your sophomore through senior years, you'll get more advanced engineering specific classes like thermodynamics, fluid mechanics, electrical engineering, propulsion, aerodynamics, all these fun, smart sounding names and really expensive, thick textbooks. So being an engineering undergrad offers you a lot of really cool things to do during the summer. We participate in a lot of paid internships or research assistantships. And that's what I did. I got to work in a laboratory with one of the professors in my school, and we actually designed nano materials. So these are kind of like materials small enough to fit on a microchip for WVU and NASA Goddard. So if you've heard of the Canadarm, that's kind of the mock-up picture that we have here. And this ring would essentially be a satellite fuel injection site. And what we were testing are sensors that could pick up toxic fuel called hydrazine. And you don't want to have that leak anywhere around your equipment. So we had these micro sensors that could pick it up in the space environment. So that was super cool. I got to work in a clean room in my junior and senior year, really hands-on. And if I could say anything about what made me successful in undergrad, I would say it all comes down to time management, because you want to have a social life. You're going to have lots of things to do with other people, and you're going to have a big class load. So it really just comes down to time blocking, managing your time wisely, going to the library, carving out places that you can be really focused, and surround yourself with people who are just as studious and committed as you are. So then I didn't want to stop there. I was really, I wanted to go deep in this aerospace path. And, but you can get a job, a really great job in engineering, as I'll kind of talk a little bit more about later, right out of college with a bachelor's degree, or you can go into graduate school, and that's where you really specialize in something that, that piques your interest. So I went to the University of Colorado Boulder, and I got my master's of science in aerospace there. You're going to take more highly specialized research-based or project-based math and science engineering classes in graduate school. And then you're going to work on a thesis, which will kind of be the body of work that you present to a group of faculty and peers at the end of your time. My thesis was on this small UAV or drone that you see in the bottom here. We were looking at renewable materials and renewable energies to create a lightweight and silent, quiet UAV. And this is us building the molds to create the composite wings. And then this is a computer model of the composite wing part that we eventually created, and you see down here in yellow. So that was really, really fun. It kind of gave me a sneak peek of what my career would be, looking at kind of everything as far as the development phase, from design to building to testing, and then working with customers on our product. And this aircraft, after I graduated, another group of students took it to the next level. They refined the design, and now it's actually being used to surveil for rhino poachers in Africa. So that was really cool. All right, there are plenty of reasons why I could tell you to go into engineering, so maybe you can find one on here that sounds attractive to you. But at the core, you know, engineers, we solve complex global problems. Pick a problem in society, and an engineer is going to be at the bottom line, working to find real world practical solutions. To me, it's a way that you can hit the ground running and make a difference in your early 20s. You have a high level of responsibility, and you get to work with talented innovators all over the place in different segments of our society. And you know, if you're interested in law, medicine, or business, engineering is a great undergraduate degree to go into any of those. Patent lawyers are some of the best paid in the world, as well as lots of surgeons, lots of doctors have their degrees in engineering, because it really teaches you to think critically and to drive home solutions to problems. Engineers travel. I traveled a lot in my work with Boeing. So if you like to travel and you know you want to have a career that opens up that part of the world to you, that's engineering. And engineering salaries remain high. They're actually the highest for a bachelor's degree of any field out there. And here's some numbers to back that up. So you can see these were 2020 numbers, just coming out with a bachelor's. This is an average of all engineering career fields. And so, and this is a little bit, these are 2016 numbers or 2015 numbers, so you'll have to account for inflation here. But you can see kind of the differential between different types of engineering. And I put little planes beside all the different types of engineering that we hire at Boeing, and all of the different types of engineers that I work with at the Boeing Portland site. So of course we have aerospace engineers, but my job, the other people on my team actually got their undergrad in civil engineering. Some of them are a lot of them actually are mechanical engineers. So we, you know, you kind of can specialize in school, but really when you get into industry, you're going to be trained, you're going to be given a lot of on-the-job training to get you prepared for the specific work that you're going to be doing in practice. All right, so this is where I started to become a real engineer. I've been with Boeing for 8 years. It was my first job right out of graduate school. I spent some time in Long Beach and Seal Beach doing stress analysis, which was mostly computer modeling. I wanted to have a more hands-on approach and actually work with the customers, work with the airplanes in service. So then I moved over and I did that for 4 years. It was some of the most exciting work I've done. I got to travel to all kinds of different customer sites around the world. This is a hangar at Etihad Airways in Abu Dhabi. I got to see some of our brand new airplanes as they were delivered. And I got to work with customers like, you know, they would have a full aircraft sitting at the gate with people ready to go. And I would be the one helping them find the solution to help them fly and take off. So that was really, really rewarding. But having that opportunity, I wanted to kind of come back into the production side and see how we build them. So that brought me to Boeing Portland 2 years ago. And I've been in the Liaison group, sort of doing a very similar role to what I was doing with the customers. So instead of fixing repairs on the full aircraft model, now I work on individual parts. And I fix them before they go onto the aircraft assembly line. So I talked a little bit about how you can travel. That was one thing that I knew that I wanted to do. And in my job in customer support engineering, we were kind of the pit crew of Boeing. So if there was an aviation accident like this one, where this aircraft vertical tail backed up into the horizontal stabilizer, caused a bunch of damage. Fortunately, nobody was hurt. But you can see this is a massive amount of damage. So they have a very specialized team of Boeing engineers and mechanics, inspectors, go out, survey the damage like an insurance company or a mechanic's body shop would do to your car, and then give you an analysis of what they needed to do to fix it. So an engineering team is actually who designs that repair, who looks at all of the components that are broken and then figures out how to put it back together. And that job brought me to 5 different continents. Here are some of the places that I've worked, at hangars, at tarmacs. Sometimes the aircraft would be on a runway like a 37 literally in the jungle at a very small airport. So in those situations, we would have to bring almost all of our tools and supplies. But I got to have like a lot of time off where I would extend my trip in these places just to see the sights and experience the culture. And that was one of my favorite parts of Boeing. All right, so that brought me to Liaison Engineering. And this is kind of a full circle here. So this picture down in the bottom left was me back in 2016. This is when I was working with Alaska Airlines on their fleet of 737s. And I have my hands on the control column here. And this part, every single 737 control column we build in Boeing Portland. And these are the parts that I'm responsible for now as a liaison engineer. So every single one of them goes through a rigorous inspection process, and they have to be exactly per design requirements before we put them on the airplane. So the pilot knows what to expect. So the pilot has the same feel every time. You don't want the buttons being in a different place. You don't even want the paint feeling differently, because it really affects the way that the pilot interacts with the plane. So if we have anything in the factory, say maybe we used a different color of paint, or we have a hole that was drilled improperly, or we have a gap. We had a clicking issue on our columns a couple weeks ago. Then it comes to my group and they say, okay, we don't want to get rid of this part. We don't want to scrap it because it's really expensive, right? Is there anything we can do to fix it? So my group works together with the mechanics, with the machinists, and the inspectors, and we all work together to see what we can do to save a part if we can. And I really love this role. I'm working from home mostly now, but when we go back on site and previously pre-COVID, um, my typical day would be kind of going out to the shop, talking with the people who make these parts, looking at the problems that we have for the day, and going back to my desk, looking at drawings, looking at models, using I still have my same calculator. I don't know if I have it here. My same calculator from high school that I used in that pre-calculus class where I learned about engineering. I still use it almost every single day. And I do use trig, and I use geometry and algebra almost every day. So if you like those classes, this is one type of career in Boeing that's highly, highly technical and lets you do that kind of work. If you like building things and taking them apart and the creativity, there are so many other careers where you don't have to do that highly detailed math still within engineering. All right, so this is my last slide here, just a little bit of advice. What I would like to hear maybe when I was a high schooler, talk to professionals in the field that you're interested in. Find out what they do on a day-to-day basis. Are they behind a computer? Are they really active? Are they going out in the field? Are they working in a factory like I do? And just kind of, know for yourself, how do you want to have your day be? Look at employment rates and industry demands. You can find these on the internet pretty easily, but I can say that engineering is one of the best careers as far as looking into the future, and there's always going to be a demand for engineers. Look at student loans versus starting salary. That is a concern. And then your teachers won't like this maybe, but C's to get degrees. My point here is, if you're not a straight A student in math or calc or science, the really hard classes, don't worry. We need engineers with all kinds of skill sets. We need good writers. We need highly organized people. We need good communicators. We need creative people who are good with web design and any other kind of design. So hang in there. If those math classes are really hard, do your best, study, get support, get tutors, but just know that when you get into the industry, it's going to be a lot different than the academic environment, and it really just requires you to have an open mind and to be able to ask for help. There's a lot of different on-ramps to get into this work. You can go to community college, you can go to a public college like me, private school, and then all of these have different advantages, especially in the technical field. You can go to a trade school for a while and get your A&P license to be a mechanic first. A lot of the highest ranking people in Boeing started as a mechanic, and those are the people that I refer to every single day to help me work on these designs. And then, leverage these resources at your school, your guidance counselor, your teacher, maybe anybody who's in the field that can help you apply for scholarships and grants. And then for girls and non-binary folks, this is a male-dominated field, but don't let that deter you. Don't change who you are to fit into a mold for your career. Otherwise, stereotypes are breaking all the time, and I've seen a huge change in tech since I started, and it's becoming more and more inclusive, especially in the past year. We have lots of affinity groups. So an affinity group is kind of like the top picture here. The Society of Women Engineers is one that I've belonged to since I was in college. And we have all kinds of these at our local Boeing sites, and you'll find them in college too. So you can really be around people who are like you and maybe who are experiencing some of the same challenges. And it's just really nice to have the feeling of not being so alone. And then, don't take comments personally. A lot of times in this field, you do have to kind of combat a lot of criticism because it is highly technical and the stakes are high. So learn to be able to take feedback. That's one of the biggest skills that you can really use to better yourself. And then don't be afraid to be assertive at all. So I think that is all for my slides. Can we see if maybe Tim's able to get back on? Maybe just speaking would work.
I see him here, Mr. Christensen. Okay.
Can't hear you, Tim. Are you speaking?
We're ready to go.
I wonder if it would be better if
Can you hear me
you
there?
turned you're still kind of choppy. I wonder if it would be better if you turned your video off, just do audio.
I think we lost him again. Mr. Christensen, are you still here?
I know Tim has had issues with power down his way. I don't know if that's still affecting. Can you hear us, Tim?
Can you hear me now?
I can hear you now.
I can see you. Okay, I'm gonna go ahead. All
Sure.
right, so my name's Tim Christensen, and I'm a manufacturing engineer here at Portland. Next, can you go? Okay. So I'm really happy to be here today, and following Lydia is going to be a challenge because she made an excellent presentation. But what I'd like to share a few things with you about today is why I chose an engineering career, some of the highlights, a little bit of detail about manufacturing airplanes and what's involved, the process, and then some suggestions for how you could kind of experiment for yourself at home or in your classroom. Next slide. So yes, it is really an honor to be here today, to get the chance to speak with you.
Mr. Christensen, we lost you again. Students, do we have any questions that you would like to ask? Please go ahead and send it in the chat window or the Q&A tab, please. Okay, first question. What's your favorite part about working for Boeing?
Um, Man, I would say just anything that Boeing just has such a wide variety of roles, really. Um, I feel like I have worked for 3 different companies in my 3 different roles at Boeing. We are a huge company with 200,000 employees in all over the world. And so if you like working with people, if you like being up close to the products that we deliver, that's totally an option. If you like testing, if you like being at the front end of development work and really working on where we're pushing the limit with new fuels, new materials, like the most cutting edge manufacturing processes in the world. There's that side too. And and if you like, sorry, my dog is here too. So I guess my point is, once you get into a big company like Boeing, the sky really is the limit. I had that advice when I started to apply. My mentor in graduate school worked for Boeing, and he said, just get in, take a job as a designer or an analyst, and you're going to have so many options open to you in those first few years, because Boeing does a really excellent job at giving you a wide view of what's available to you in the company, and allows you to kind of like test drive a lot of different roles. So I think it would probably be that. Like I feel like I was given every opportunity, and I've had great managers who said yes to just about everything that I've asked for.
Okay, thank you. Your next question. What is the most fun part of your job?
Most fun. I would say it's the satisfaction once you figure out the solution to something, and you have been working on it with a team, and everybody comes together at the end and say like, oh wow, like I can see the light at the end of the tunnel, I can see a path forward, and you contribute to kind of like the big mission of what your team, your site, your business unit is doing. Like I get to shut my computer down or walk out the door every day, um, knowing that I made progress, knowing that I learned something. I'm a lifelong learner. Um, I love learning new skills and challenging myself. So I feel like I get to do that in the job. And I've moved jobs every 3 to 4 years, which is typical inside this company now. And so I've always had the ability to do that, and to kind of just keep pushing myself personally and professionally.
Tim, do you want to, since you're back, do you want to try to go through your slides again?
Well, if you'd like, how much, I don't know how much time we have left here.
Yeah, we've got about,
Maybe
I think, probably 20 or more so minutes. If you want to try that, and then we can hit up the rest of the questions that have come in too.
Sure, sounds great.
I think this is where we left off. Hopefully we didn't lose you again, Tim.
I can leave this up, and then if Tim jumps back in, we can go back in. Are there any other questions?
Yeah.
Is.
Okay. Darren, do you want to go ahead? Okay.
Yeah, sure. What do you think is the best way to get into aerospace engineering?
Like to get into, I guess that question could be to get involved, get interested, or to get into school. I really wish that I had a little bit more experience mechanically before coming into this job. I mean, I kind of grew up taking apart bikes with my dad, but I wish that I had a little bit more experience, like looking at engines and just getting a feel for kind of like how tools work and, just sizes of bolts and nuts and things like that. So if there are extracurriculars in your high school or maybe like a vocational center, if there are teams that you can be on that where you're actually building hardware, that's going to give you a huge advantage, especially in aerospace engineering school in these programs, because you're always going to do some sort of design build challenge.
That's a great answer, and I'll just say this is my second session today that I've moderated. One was on facility design, and both of the presenters said that they wish that they would recommend students consider vocational classes like wood shop or welding, or I don't know, we had like a small gas engine repair in our high school, but having that hands-on work as opposed to just doing the theoretical exercises. Tim, are you back on? Did you have anything you wanted to add to that? All right, we're gonna keep moving forward. If you jump in, Tim, that'll be fine. This is a great question that I don't think I've ever had a student ask before for anybody, but what are your hours like at Boeing? Is your schedule flexible, and are you granted occasional days off, or is it more like a 9 to 5?
That is a good question. I like where you're thinking, because like that goes back to the reason that I chose engineering over something with a similar salary like law or medicine. Honestly, engineering is one of the best careers for giving you work-life balance. Usually you're going to have a pretty regular schedule, especially if you work for kind of a big established company like Boeing. That's completely different if you're in the startup world. If you work for SpaceX, like good luck trying to have a sub 60-hour work week. But people usually do that for a short time and for good reason. So not discouraging the startup world at all. You're just going to have a lot more hours. I like Boeing because I do have a set start time every day. My team's initial morning meeting is at 10 till 7. It's a little early because we're a factory. Other parts of Boeing start around 8 o'clock. And then I can usually be out the door after 8 or 9 hours and turn off my phone. I've taken 3 to 4 week long sabbatical vacations almost every single year. I've done distance hiking. I've gone to India for a while, and because I have the paid time off to be able to do that. And there really are not a lot of other careers where you're making six figures and being able to do that.
Looks like I was on mute. What is the most challenging aerospace engineering project that you've been involved in?
I would say, going back to those pictures of the aircraft, on the collided aircraft. When I was on this team, there would be an accident, say today. They would have to send our team out tomorrow, and you would have like an email with some pictures and a record of what happened from the customer. And that's just about all. And you would be the one who landed on site with your team and had to look at this damage and say, this is what I think happened. We need to look at these different parts of the aircraft. And then it's not very straightforward on what you have to replace. There's oftentimes a lot of hidden damage. So I did this really complicated repair for Ethiopian Airlines where we actually had to, it was another wingtip incident, and it actually buckled, like made the lower skin really wavy. And so we had to take off that entire lower skin. It was almost, one segment is about 100 feet long. So we took that entire thing off and we had to put up a new lower skin. And this skin is like an inch and a half thick. So almost 100 feet by an inch and a half thick. Really, really complicated. Hundreds of fasteners that go in there in really, really close tolerance holes. So we had to design a complete structure to be able to hold that. And then we got it up there and we noticed that because the hangar we were in is not temperature controlled, we were having temperature swings of about 40 degrees during the day when the sunlight would come in, and then into the night where it would cool down. And a large, long part like that made of metal is going to shrink and expand. So our fasteners were never in the same place. So that was extremely challenging, and it required us to monitor the temperature, monitor the loads on we call them jacks, which are putting this new skin up on the aircraft. And we had to put it on in the same conditions every day. And it took us I think close to 3 months all in all to be able to do this. And it was one of the most challenging repairs Boeing's ever done in our history. So it was really exciting and innovative, and it was really rewarding to be a part of a team that was doing something like that.
Yeah, so just to add to that, Darren, I too had a similar experience working on a fleet support project. We had an issue with the 737NG where there was a design flaw that caused a cracking in the trim tab on the elevator, and along with 5 other modification sites around the world, we had to very rapidly support the entire fleet of aircraft, which was over 2,000 airplanes, with replacement elevators that were remanufactured to repair that flaw. And so there was a great deal of pressure to get tooling and facilities in place to support that, as well as the materials required to complete the work and get those elevators back on those planes and the planes back in the air. And that's one of the things that we do have to battle. There's often a lot of time pressure, but we have to ensure that we take the time to do every job correctly. So that's a difficult balance to achieve sometimes.
Great. Before we take the next question, I just wanted to acknowledge, I saw in your slides, Steve, I know we had some issues with the slides and the connection, but this is the 40th year since your first Engineers Week program event. Is that right?
Yeah, that's absolutely right.
I think that's fantastic. And, you know, for the students on the call, I would just encourage you go down this path, remember this event, and when you get into the profession and you start working and you know, consider joining a group like this. Maybe it's not in Portland, maybe it's somewhere else, but you know, give back to the other students and the folks that are coming up and thinking of joining the profession as well. Let's see. The next question is: there anything that we can do now to help us prepare for working at a company like Boeing? Tim, you want to take that first?
So that's a really tough question, because Boeing, for example, is such a large and diverse company. I would say the best thing that you can do is of course focus on your studies in school. Try to become as proficient in mathematics and science, applied sciences, as you possibly can. And Lydia is correct. C's do get degrees, but the better grades you have, the better opportunity and placement you'll have. And then from there, I would look at every opportunity to apply or just think about the applications of engineering principles in any job that you might have during high school or college. I worked in a factory that was kind of a huge collection of conveyors and pipes and everything, and it was really boring working there, but I was able to occupy my time thinking about how that mechanism worked, um, all the effort that went into producing it and getting it operational. There's a lot that you can learn just on your own by thinking about how to apply engineering skills.
Anything to add on to that, Lydia?
Yeah, all of the above that Tim said. One thing that came up for me is kind of anything you can do to expand your comfort zone is going to help. When I was traveling and doing this repair work, often I would be the only woman on the team, and I would be traveling halfway across the world by myself. So that, I grew up in rural West Virginia. That was a big change. And I had traveled a little bit before that job, and I like travel and adventure. But this really it pushed me to expand what I thought I was capable of navigating by myself a lot of times in these airports, and learning different languages just to be able to communicate with people, learning the transit systems in different countries. So it's kind of like these things that you don't think about, but having those skills made me a successful engineer because I was so adaptive. They knew that they could send me to just about anywhere. And that started with kind of like it goes back to really small ways of expanding your comfort zone, sitting with a table of people you don't know, learning a new language, joining a club that you would probably never join. So really just any way that you can expand yourself personally, I think is going to help.
Great. Next two questions are somewhat related. Maybe as a high schooler, what are good ways for me to get involved in aerospace engineering? And maybe simultaneously, can you talk about what summer internships might have looked like for you both in college? Why don't you go first, Lydia?
Yeah, so at the high school level, I would go back to being part of, if there's anywhere that you can get this practical experience of building things. So volunteer projects, I know the Scouts do this a lot, and I work with the Girl Scouts a lot, and they have a big focus on STEM. So any of these design competitions that you can get involved in early is going to give you a leg up to then those design competitions or projects in college. And those projects are what you're going to be talking about when you interview for a company like Boeing. Almost all the interview questions are kind of related on when did you work in a team on a highly complicated problem, and how did you get to the solution? So this can be Habitat for Humanity. These can be vocational projects that we talked about that might be available in your high school, but look around your community, places like Engineers Without Borders or Society of Women Engineers, just to kind of give you that really hands-on experience. And that's going to help you apply for scholarships, grants, fellowships as well.
Yeah, so towards the end of my presentation here, if you want to share that later, there's a glider project that the Civil Air Patrol developed, and I did this actually when I was working on my graduate degree. This was just a simple way to demonstrate how to optimize a design. But anyway, you can search out things like these. With the Civil Air Patrol, for example, you can join that organization. You can learn to fly. You can learn a lot about aircraft and get a lot of life experiences. And just seek out any opportunity that you can. a diverse range of experiences. You never really know how much it will benefit you or how you can apply it. And uh, just look for any opportunity you can. That's all I could add.
Okay, great. I think Lydia, you might have touched on this just a little bit, but how does this path or this career relate to medical and law careers?
That's a good question. Yeah, so I talked a little bit about patent law. So basically, any company that is developing a new design, a new innovation, Boeing has hundreds of thousands of patents, I'm sure. We actually have to have lawyers to create that package. And a lawyer who has a really solid base in the practical engineering and the technical work, because that's what they're going to be embedding into these legal documents. They're kind of a technical document, almost like a blueprint melded with a contract. So it's kind of like you learn to speak a technical language. It's like computer programming. And then you insert that into the legal world. That's a super, super powerful skill set.
Great. Let's see. You mentioned sabbatical. Maybe we could just talk about what the difference is between sabbaticals, typical vacations, and then weekends and days off.
Yeah, Tim has been working here longer than me, so maybe he can start and I'll tune in. I'll chime in.
So I've never had an opportunity really to take time away from work, but we do have those programs. It is possible to take a leave of absence with the approval of your manager. For instance, if you want to pursue an advanced degree, um, uh, my bachelor's degree program was at a traditional university um, where I had to be there. For my master's degree program, I did that almost entirely using distance learning. Um, but if you did have a reason that you had to be on campus, I think even the most liberal universities now require you to spend a certain amount of time on campus. So you could, in theory, get your foot in the door here at Boeing, for example, with a job, make use of our educational programs that we have to obtain your education. And then when the time came where you had to do that on-site activity, you can take a leave of absence to pursue that. And the key is to, like I said, get your foot in the door, get connected with a manager that would support you in that, and you can pretty much write your own ticket. It's a pretty awesome opportunity, and I'm very thankful that I was able to make use of it.
Yeah, so that has me thinking of benefits. Boeing really leads the aerospace industry year after year in the benefits package we offer. Starting out as a new year one employee, you can expect, I think, 10 days vacation and then 10 days sick time. In non-union parts of the company, those are combined now into a pot of 20 days straight paid time off. And then I think we get something like 12, everybody gets general 12, I think, holidays per year. So you get like Christmas Eve to New Year's Day, Thanksgiving, 4th of July, Memorial Day. And that's that's actually a little bit better than a lot of other companies. I have a lot of friends in different parts of aerospace that have to work the December 26th through the 30th. So I really like that we have that big chunk at the end of the year. And then basically to be able to take the time off that I did, I saved up all of my vacation, and I was working in a job where we had to rotate weekends. So I would stack my weekends and essentially work 36 hours in a 3-day time period, and then be able to take that 36 hours off the next week. And I did that at the beginning and the end of my trip. sandwiched my time in the middle, took a month off. And I've always worked on teams where we kind of split the work. I've been in leadership roles too, where I could kind of transfer my work to another person for a while. And if you go in with your intentions of kind of the work-life balance that you want, and you're very clear with your management team and your team in general, I've always found that teams are willing to work with you, and there's always a way as long as you are really good about communicating. You can even put this into your goals for the year. You know, I want to take off 4 weeks in October. How can we make it work? You can imagine that this also makes it possible for people to have families and to plan time around families. And we're becoming better and better with those life adjustments every year that I've worked here.
Great. Let's see. Where do you see the future of aerospace going?
So I think one of the biggest challenges facing aerospace is environmental. I think there's huge opportunity for people that can develop the next synthetic fuel that's going to support aviation. There's some inroads being made in that, but I think there's a long way to go. And I think continuing to keep aerospace manufacturing on a path that supports sustainability, the environment, that is good for the planet. I think that's the key to the future.
Yeah, I would agree, Tim. That is our biggest challenge, and it trickles down into how can we make our materials more efficient. So we're looking at lighter materials. That's why we're making our newest aircraft out of composites, and we're looking at biofuels as well. And then kind of what Tim and I work closely with is in manufacturing is kind of like, how do we reduce waste in manufacturing? How do we bring our excess metal shavings or any of our energy waste, like how do we actually put that back into the energy loop? And we have a whole subset of engineers looking at energy efficiency and making improvements in that area in what we do.
Cool. This is kind of put you both on the spot a little bit, but have you had any periods of time where you've regretted going into this profession?
I mean, I think that it's kind of unfair that we expect outgoing high schoolers to decide what they want to do for the rest of their life at that age. You know, in a lot of other countries, you kind of have some time to decide. So I felt like I chose this career when I was really young, but at the end of the day, I think I would be happy doing anything in science. You know, at one point I wanted to be a marine biologist. At another point, I wanted to be, um, uh, I wanted to be a pilot. Yeah, and that's kind of what brought me into aerospace. But engineering is just so broad. Like if you don't like one company, then you can really go a completely different direction. Say you don't like manufacturing, you can go into research and development, or you can go into testing, or you can go into product design. So it just comes down to kind of like, do you like to solve problems? So I don't know. I think like I'm 32, and so there are a couple paths I sometimes wish I would have taken, things that are a little bit more creative, even though this job is extremely creative. But I love it every single day. Like the work is just so satisfying, and seeing kind of where a lot of other people are in their careers right now, and the challenges that other job roles would have brought me to financially. I'm just glad that I chose this because I've been able to afford the lifestyle that I've always wanted for myself. And that goes back to like the time off and the ability to do all these things that I want to do financially.
So we probably have time for one more question. Maybe you can tackle these both at the same time, two of the questions. One is, how important is a BS in aerospace engineering versus a BS in mechanical? And for getting into aerospace engineering, would you recommend a traditional college or a trade school?
I'll let you go first, Tim.
Yeah, so it all depends on what your goals are, or what you believe your goals are, at at this point in your life. If you have your heart set on designing wings, or something of that nature, maybe aerospace engineering is the perfect fit for you. But like for myself, I really didn't know exactly what path I wanted to go down. So uh, for me, the right answer was I started out with a bachelor's degree in technology and industrial technology, um, and then I've been able to build that into the career that I have. So for me, the answer was a kind of a broader, more general program. For example, like mechanical engineering and civil engineering are sort of like that. But it just all depends on what you want. And then the other aspect of it is, as you go through your life, you'll find that your interests change. Also, technology changes, and there are constantly new opportunities, that you will have interest in or want to explore. And so you just have to be adaptable, and then constantly learning, constantly uh, seeking what's new and what interests you, and to expand your expertise. And that's kind of a lifelong endeavor.
Well, we're at the hour. Maybe I'll just throw this last one out there because it's quick. Have you guys ever worked overtime?
Oh yeah, plenty
Yeah.
of times, but I've been paid for every hour very, very well.
Good. Well, I want to just take a second to thank both you, Lydia and Tim, for participating today. Hopefully for the students on the call, it was interesting. You guys got something out of it and some interest in another part of the profession for engineering. Take advantage of the other links for the different eWeek presentations, seminars, and technical tours that are on the NEPRIS website. And really appreciate everybody's time this morning, and hope you all have a great rest of the afternoon. So I think with that, we can sign it off.
Thank you, everyone. Great luck to you, and I really appreciate getting to talk to you today.
Yeah, best of luck. Thanks.
All right. Have a great afternoon.